Hey everyone, welcome back to Cruise class. In today's video, we'll be following up on our differentiation rules, and this video we'll be looking at a special rule known as the product rule. Now, in the last video we looked at the exponent, the ln, the sine, and the cosine rules. Now, the product rule is a bit different. As the name suggests, product, it implies multiplication. Now, the product rule is used when you want to find the differential of a function multiplied by another function. So this u represents a function with x as a variable, and this v represents function with x as the variable as well. Now u is being multiplied by v. We wanted to find the differential of u times v with respect to x, given that both of them are two different functions, but both of them also have x as their main variables. Now, to do that, we have to follow this rule. We're going to multiply the function v by the differential of the function u, du dx. Then we're going to plus multiply the function u by the differential of the function v, dv over dx. And this is the product rule. Now let us try and apply it. Now in this case, it says if y is equal to x to the 4 multiplied by e to the 2x, we have a power rule and we have an exponent rule, but they're being multiplied. Both of them have variables of x. This is a perfect time for the product rule. So the first thing we will do, we will call one u and call one v. It matters not which one you call u or v, either one will work. Now we call this one u, we call this one v. So if u is x to the 4 and v is e to x, we will have something looking like this. We first have to label u. U is x to the 4. We got that from the top before. So the differential of u will be 4 times x raised to 4 minus 1. So it will be 4 times x, 4x, and raised to 4 minus 1. We use the power rule to differentiate this. And then over here we have v being e to the 2x, and to differentiate v we follow the exponent rule. So it will be 2 times everything. So it will be 2 multiplied by e 2x. So now we have u, we have v, we have the differential of u and the differential of v. So we have all the terms that are needed to satisfy our rule right here. Now, moving further, if we want to differentiate the function y with respect to x, because remember, y is the function, so we want to differentiate y with respect to x, we have to follow the product rule, v times du dx. V would be e to the 2x multiplied by du dx, which is 4x cubed, plus u, which would be x to the 4th multiplied by dv dx, which is the differential of v, as you can see here. So this would be v multiplied by du dx plus u multiplied by dv dx. And then from here, we just carry out regular multiplication. So as we can see here, bring the 4 out to the front, remove the bracket, bring the 2 out to the front, remove the bracket, and we have our differential. We could leave it right here if we want, but I can take another step further by, let me see, factoring out 2. 2 is a common term. We can also factor out e2x, because e2x is a common term. And we can also factor out x cubed, because x cubed is a common term. So when we factor out all of those, we are left with this as our differential. However, if you wanted to leave it at this stage, you could have. But long story short, this is the product rule, and we use it when we are differentiating the product of two different functions with the same variable of interest, which is x in this case. So next class or next video, we'll look at another differentiation rule.